So we are on page 75 of our textbook. The reading can be found on Schoology under today's date, November 2nd. I'll wait till you're showing me you're ready. We're following along with our finger or our pencil. Okay. Reshaping Earth's surface. Have you ever seen bulldozers, backhoes, and dump trucks at the construction site of a building project? You might have seen a bulldozer smoothing the land and making a flat surface, or pushing soil around and forming hills. A backhoe might have been digging deep trenches for water or sewer lines. The dump trucks might have been dumping gravel or other building materials into small piles. The changes that people make to a landscape at a construction site are small examples of those that happen naturally to Earth's surface. A combination of constructive processes and destructive processes produce landforms. Constructive processes build up features on Earth's surface. For example, lava erupting from a volcano hardens and forms new land on the area where lava falls. Destructive processes tear down features on Earth's surface. A strong hurricane, for example, could wash a part of Florida's shoreline into the sea. Constructive and destructive processes continually shape and reshape Earth's surface. A continual process of change. Popcorn. Braylon, read loud and proud for me, please. I'm sorry, I still have people who are making noises. Our bodies are turned forward. We are following along with our finger or our pencil. Thank you. Go ahead, Braylon, loud and proud.
Imagine standing on a mountain such as the one shown in Figure 1. In the distance, you might see a river or an ocean. What was this area like thousands of years ago? Will the mountains still be here thousands of years from now? Landforms on Earth are consistently changing, but the changes often happen so slowly that you do not notice them. What causes these changes?
Perfect. Popcorn, Andrew. Or Asen, or Radiance, where are you? Asen, is your mic working today? Okay, I would like Andrew to pick up where we left off. We're at weathering.
Print it.
Okay, well, I put it up on the screen so you can also read it for us. So we're right at weathering.
Oh, okay. One type of destructive process that changes the Earth's surface is weathering. The breakdown of rock. Chemical weathering changes the chemical composition of rock. Physical weathering breaks rock into pieces called sediment, but it does not change the chemical composition of rock. Gravel, sand, silt, and clay are different sizes of sediment.
Perfect. Pick up where he left off, Joel.
Okay, weathering agents. Water, wind, and ice are called agents or causes of weathering. Water, for example, can dissolve minerals and rock. Wind can grind and polish rocks by blowing particles against them. Also, a rock can break apart as ice expands or plant roots grow within cracks in rocks.
Perfect. What is it called when ice expands and breaks rock? What is that called? What is that called? It's a type of weathering. What is it called? Helen? Frost wedging, right? It's when frost wedgie, when ice wedging, when ice gets in your crack, it's called an ice wedgie. Remember we talked about that? I said, right, a wedgie is when you get your underwear in your crack, right? Let's be honest. It's true.
It's true.
It's true. But when ice gets in the crack, it's called an ice wedgie. When roots get in the crack, it's called a root wedgie.
That really happens.
Right? Do you think you'll forget it now? Right? When ice gets in the crack, it's an ice wedgie.
And when wedges get in your crack,
When roots get in the crack, it's called a root wedgie. Show me you can handle it, please. Show me you can handle it, please. Thank you. Go ahead and read the next paragraph for me, Diego.
Different ways of weathering. The mineral composition of some rocks makes each of them more resistant to weathering than other rocks. The differences in weathering rates can produce unusual landforms as shown in figure 2. Weathering can break away less resistant parts of the rock and leave behind more resistant parts.
Perfect. Just like in the Bill Nye, we saw those arches that were forming because in the middle part of the rock, it was weaker, but the outsides were stronger. So the only part that was dissolved was the middle part. So left those arches. So we're going to go back to our notes and let's fill this in. Constructive processes build up. Yep. We're not build down, tear down. I always like to think of constructive like a construction worker. And what do construction workers do?
Move bricks.
They build.
Oh.
They do move bricks, but it's to build. So I like to think that construction workers build. Our examples are when lava hardens and builds new land. And this one's a big one. We'll talk about it later on in this reading. Deposition is considered constructive. When I think about construct, a construction paper, you use it to build stuff, like or create something, right? Use words that you know to help you with words you don't. What's another word for destruct? My mobile learners, Radiance, I don't know where you went, honey. My mobile friends, what's another word for destruct?
Destroy.
Destroy, perfect. To destroy or tear down. So what do we think destructive processes do then? What do you think destructive processes do then? Kyle? If constructive processes build up, what do we think destructive processes do?
Break down.
Break down. Perfect. What are things that tear down or break down Earth's surface, Joel?
Sand.
Okay, sand is an example of what's left behind, right?
No,
What?
but like when they say like it hits the thing, yeah, and it shaves. Like,
Shays. So, but that's an example of what? That we remember we talked about it last week.
Example of water.
Look at what I'm writing.
wet.
What am I writing?
Weathering.
Weathering. Very good. And I'm going to say an erosion as well, because erosion is what moves it. And also natural disasters. Break stuff down. Like hurricanes, perfect. I'm getting really concerned because I have one person in particular who won't stop talking. Thank you. So weathering is an example of constructive or destructive. Which one? Call it out.
Destructive.
Destructive. It destroys stuff. Why? Why is it destructive? Why is it destructive? We kind of just talked about it. Maddox?
breaks things down.
Perfect. Weathering breaks down rocks. Perfect. Remember that EA stands for breaks. Jace, do you have this paper with you? Andrew, I need to see your video. Thank you, sweetheart.
I forgot about it.
Can I see everyone, all my mobile friends? Can you hold this paper up so I can see that you have it?
Oh.
Thank you, Radiance.
The one that's on the screen.
I want to see that you guys have it in front of you. Thank you, Daniel. Thank you, Andrew. Asen, where's yours? Shariah, where's yours? That's not acceptable. I need to see it now, Asen. If it's already done, then you should have it. Jace, where did you go? Do you have this paper, Jace? Why not? Why not? Can you unmute yourself, please? It was sent to you on Friday. It was also uploaded into Schoology to be printed. Do you have a printer? Okay, then you need to be printing this right now, please. Okay, thank you. I'd like to see it printed and held up once you get it printed, please. All right. May I please have, we're moving on to erosion. Can I have someone new read? Cody, start with erosion for me, please.
Weathering material is often transported away from its source. Erosion is the removal of weathering material from one location to another. Agents of erosion include water, wind, glaciers, and gravity.
That's important to know. Gravity meaning is what, like, it makes it fall, right? Gravity is what makes stuff fall. So gravity is going to, like when a boulder falls, it's because of gravity, right? It's not going to float, but it's going to fall down a mountainside, or landslides are caused because of gravity. Maddox, can you read the rate of erosion, please?
Like weathering, erosion occurs at different rates. For example, a rushing stream or strong wind can erode large quantities of material quickly. However, a gentle stream or a light breeze might erode a small amount of material slowly. Factors that affect the rate of erosion include weather, climate, topography, and type of rock. Weathered rock moves faster down a steep hill than across a flat area. And erosion occurs faster on barren land than on land covered with vegetation.
Perfect. So I want to break this down for a second. Think about if you're riding your bike. You're going to go faster down a steep hill than you will a flat surface, right?
Yeah.
Same thing with a rock. If you are riding your bike and there are lots of trees, are you going to go faster on a place where there are less trees or more trees? Less trees, because you don't have to navigate through the trees, right? So think of when you guys think about this, think about like when you're riding a bike, it's very similar to the way that a rock is moving. You're going to move faster down a steep hill than you would if you were on flat land. If you have to, I've been snowboarding and skiing before, and I always go faster down areas where there aren't any trees that I have to kind of navigate around versus areas where there are a lot and I have to slow down and kind of move around them, right? Perfect. Yes, Joel.
If you slow down too hard when you're doing that, like down a steep hill, like you would just like flip over or something like that. Or like
You can, it depends on how you stop. There's a lot of other factors that are involved in that. We'll talk about that in Unit 4 when we talk about force, motion, and energy. The rate of erosion and rock type. The rate of erosion sometimes depends on the type of rock. As we saw in the gizmo, right? The granite eroded slower, weathered slower than the shale. Or we should have realized, right, if we did the gizmo. Weathering can break some types of rocks, such as sandstone, into large pieces. Other rock types, such as shale or siltstone, can easily break into smaller pieces. These smaller pieces can be removed and transported faster by agents of erosion. For example, large rocks and streams usually move only short distances every few decades, but silt particles might move 1 kilometer or more each day. Rounding. I'll wait. There's a lot of movement. Rock fragments bump against each other during erosion. When this happens, the shape of the fragments can change. Rock fragments can range from poorly rounded to well-rounded. The more spherical and well-rounded a rock is, the more it has been polished during erosion. Rough edges break off as the rock fragments bump against each other. Differences in sediment rounding are shown in Figure 3. Have you ever seen a rock polisher?
Yeah.
They look like cement trucks.
Yeah.
And they continually move the rock in circles until they're very smooth. Do you remember the Bill Nye where the claymation and it was like, Grandpa, how come you're so rough, smooth and I'm so rough, right?
Over years.
And he's like, over years of erosion. But that's true because the rocks hit each other and all those sharp edges get snapped off and eventually they become really smooth.
You know what you had last year? Like with the black thing?
I did have a rock polisher last year. It wasn't mine. You didn't let me borrow it. But that's how you get those smooth gemstones that you might see in jewelry.
I have it easy get. Can I bring it?
Absolutely, we would love that. I think it would really help to clarify what rounding is. We're going to be practicing rounding in our lab on Friday.
So can we do that with Play-Doh or Play-Doh?
You'll see what each one is used for. Sorting. The erosion can also affect the level of sorting of sediment. Sorting is the separating of items into groups according to one or more properties. As sediment is transported, it can become sorted by grain size, as shown in Figure 4. Sediment is often well sorted when it has been moved a lot by wind or waves. Poorly sorted sediment often results from rapid transportation, perhaps by a storm, a flash flood, or a volcanic eruption. Sediment left at the edges of glaciers is also poorly sorted. So, like we'll notice if you go to the beach, typically what ends up on the beach is the smaller stuff, but what ends up when you're in the water, you might get larger rocks because they weren't moved as far, right? Have you ever noticed that? Okay, so let's go back to our notes. Erosion is the removal, and you could even say movement, so the movement or removal of weathered material, meaning that it's already been broken down. What does the O in erosion stand for? Do you remember what we talked about? The O in erosion stands for? Moves. Very good. Quick question. Anybody can answer this, my mobile friends or my students in class. How do you get from, and raise your hand, how do you get from one place to another? Like how do you personally get from one place to another? Leon. Okay, but what on the land? Like how, if you're trying to go to your friend's house over the weekend, how do you get in there? A car, okay? All right, hold up. Shiloh, what does the car drive on? How does it get there? Wheels, okay, but was it just drive? How is it? Energy, okay. So, but what surface does the car drive on to get there?
Oh, please.
Lucas?
A road.
A road. Watch this. Hold up. Watch this. A road, right? If you want to move, you go on a road. If a rock wants to move, it goes on E road.
So funny.
If you move, you go on a road. A rock moves, it goes on E road.
What if you don't drive a car?
See what I did there?
I drive a dirt bike.
Huh? You're not gonna forget it now.
Fancy pun laugh made me laugh.
What if you fly?
All right, hey, don't make it more complicated than it is. We normally get somewhere by driving on a road. So if we want to move, we're going on a road. If a rock is moving, it's E road.
Wait.
A road? A road? Get it? E road, a road? Okay.
Wait. So erosion makes the thing go somewhere. Left it and then you go to a new.
A new place. It goes from one location to another.
So that's erosion.
Erosion.
Weathering is where it gets picked up by something.
Weathering is when it's broken down. So think about it like this.
But like when ice.
Yes. So let's think about it like this. How many of you ever moved from one house to another house? Okay. All right. I did last year. Is it easier can you just pick up your whole house and move it to a new place?
Yes.
No.
Well, you could.
All right, hold on. I'll wait. Even if you could, you'd still have to empty everything out of the inside,
Yeah.
right? Okay. So, in order to move, you have to break it down into small pieces first so that it's manageable, right? You can't just pick it up and move it. It has to be broken into small pieces first. So that's the weathering part. That's the breaking it into the small pieces so that it can be moved.
And then the erosion.
Then once I'm ready to move, I drive my broken down house on a road. Does that make sense? So I break my house apart. I break all my stuff apart to make it easy to move. Then when I'm ready to move it, I drive on a road to move it. And then, to be continued. In a second. Yes, Kayla.
It's possible not to move houses with everything inside. Mobile houses.
It's not. You have to move everything out of the house.
Oh, you do?
Yes. Because they can't lift it. And they can't lift it. And then everything inside would fall anyway. So even if you were lifting a mobile home, you have to take everything out of it because then it would fall. Yes.
Isn't it like when you lose a tooth? So you put on your pillow, and the tooth fairy grabs it and moves it to a different place.
You can, if that's what makes sense to you, then you can.
Yay!
So, oh wait. Weathering and erosion occur at different rates because of rock type. So, like our example would be the gizmo, if you remember. Granite takes longer. Then I'm gonna say then shale, but you're also right, than limestone. The rocks have different mineral types or different minerals in them. Some are weaker than others. I always think about it like this. Which one is easier to dissolve in water, Splenda, or in coffee or tea, Splenda or regular sugar?
Regular. No, Splendid.
Splenda is easier to dissolve. So because it has different properties. Rocks have different properties too.
So it's basically like sugar.
Is it Splendid sugar more sweeter too?
Well, it's fake sugar. Rate of erosion can depend on rock type, the size of the rock, and natural forces. So, like, for example, a gentle stream. A gentle stream will not erode as fast as heavy crashing waves. Yeah.
Wait, a gentle stream will not erode.
As
Rocks?
fast,
Because it's making it seem like
because if the stream is moving very slowly, it's not going to have enough force to move big, heavy rocks.
So rocks. Wait, like a gentle stream will not
Erode
rocks.
as fast. You could say erode rocks, but
Okay.
it's implied that I meant rocks. Yes. Yes.
I think we're doing good.
Asen, where are you? All right, good. I should be able to see you guys to make sure we're focused.
If you're both tubing, you see a whole bunch of rocks that are all like flat.
Because when you're going tubing, the water has to be moving fast, right?
Yeah.
Or it has to have a lot of force. So that force is going to erode rocks faster than it would.
And that means you're gonna get stuck on them a lot.
Yeah. If it wasn't fast moving, then you would be stuck.
Like one of the slides at the park. You can't move.
Rounding is the same thing as abrasion. It's when rock fragments bump against each other. And it makes the rocks rounder over time. We're going to be practicing this in the lab. Remember I showed you this with the coal? When I rubbed it against each other, the pieces broke off?
I never saw that.
I showed you that on the camera. Yes. I 100% showed it to you on the camera. Remember I brought it over here like this?
Things up there.
Oh, it's real cold.
And eventually it smooths it out.
That's what you get in your stock and it will be nice.
Wait, is that real cool?
No.
Yes.
No. Yeah, it was really.
Yes, it is real.
You know those fake rocks?
Oh no, it's not.
They look so
Hey Landry, we've been having an issue with the off-topic conversation today, or not even the
We're
off-topic.
discussing like, gold.
It's on topic, but are you done with this?
Yeah.
Okay. We've just been very talkative today. Erosion can also affect this level of sorting of what's left behind. What are the broken down pieces of rock?
Sand.
What is sand an example of?
Grain.
Sediment. And we already said that the sediment is the small broken down pieces.
You can't smell sediment without an S in it.
What do you for?
Sand is an example of sediment. It's that broken down, what's left over. I like to think of it as like rock crumbs, if you will, like the little crumbs that are left over from rock. That's okay.
Is it?
What, love?
I can't see like below the is brown. I can't.
It says abrasion. ABRASION.
Oh, I thought it was molding.
I'm sorry, love. I'm trying to write clearer. But abrasion, remember I said that the first aid term for a skin knee is called an abrasion?
When you feel the pain?
No, when you skin your knee,
Oh my God.
in first aid, that's called an abrasion. Like the wound itself, it's called an abrasion. It's not called a skin knee, it's called an abrasion because it's just that grinding of your skin against a surface. Just like abrasion with rocks is when a rock grinds against another rock or a surface.
Are you talking about
No.
like carpet burn?
Carpet burn is an abrasion.
It is or isn't?
It is. Carpet burn is an example of abrasion.
Oh, okay.
Let me see. I want to see. All right, so, and this is so crazy. Look, I just Googled abrasion, right? I just Googled abrasion. Look what comes up. Skin knees. So, the reason I bring that up is because when I was in high school and I was taking paramedic biology, like I was taking first aid, I didn't realize that was really called an abrasion. And we've all experienced one, and carpet burn, or, falling down and skinning your knee after, falling off the skateboard or whatever it is. But in first aid, if you were to go to a doctor, they'd be like, "Oh, it looks like you've got an abrasion." They wouldn't call it, "You got a skin knee or skin elbow." If it's infected, it would only be infected if you didn't put an antibiotic cream on top.
Is it blister or is like not one?
You said a bruise?
Blister.
No, well, a blister that's actually a great question. A blister can result from friction, right? Let's say for me, I get blisters on my feet sometimes when I'm running, and it's because my feet are rubbing against my socks, right? So it's still going to be grinding against, but a blister is the body's natural response to try to heal it itself. So it fills up with liquid to try to create like its own little bubble barrier.
Oh, and then we ruin it to pop it?
That's why you should not pop a blister, because a blister will get infected that way. All right, what were your questions real quick? We'll address them. We are going to finish the second half before we finish our gizmo. So, because I think I want to really spend a lot of time on the landform section. So if you notice this second part, we talk about deposition and landforms. This is the part that's going to be crucial to us on Friday when we do our lab. So if you are watching the YouTube video, just know that there's going to be a part 2 to this video that's going to be released on Wednesday the 4th.
And that's when you have tutoring.
Also, when I have